Hi guys, welcome to our video lesson to cover the second half of 3.1. So in class we learned how to simplify radicals, and the reason we did that is because when we're solving by taking square roots, we need to give our answers in reduced radical form. We do not want any decimals. So we're going to do a few examples in this video of solving quadratic equations by taking square roots and finish the rest in class. Your learning target is I can solve quadratic equations of the form ax squared plus c equals 0 by taking square roots. Our instructions say solve each quadratic equation by taking square roots. Give exact answers. Express imperfect roots in simplified radical form. Okay, so when we are solving quadratic equations by taking square roots, the number one goal is to get the x squared by itself so that we can take the square root of both sides. So in letter A, the first thing I'm going to need to do is add 16 to both sides. So now I have x squared equals 16. Now that x squared is by itself, I can undo the squared by taking the square root. So I have to do that on both sides. Now, when we take the square root as a problem-solving tool, we have to account that you could have a positive square root and a negative square root. The positive and negative square root of 16 is 4. So this actually has two solutions, plus 4 and minus 4. Okay, let's look at B. B is a lot like A. X squared minus 9 equals 0. So we just need to add the 9 over. So that leaves us with x squared equals 9. Now taking the square root of both sides, we know 9 is a perfect square, and it has two square roots, plus or minus 3. Okay, letter C. It looks also a lot like letters A and B, but we will see soon that it is a little different. So x squared minus 24 equals 0. We are going to add 24 to both sides, which now gives us the equation x squared equals 24. Now we're going to take the square root of both sides, and here is where it becomes different. 24 is not a perfect square. So what we need to do is we need to write this as x equals plus or minus the square root of 24. But then we need to simplify this radical like we've learned how to. So in this video, I'm going to be using the method that we find the perfect square, the highest perfect square that would go into 24. So our perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and I could keep going, but just to refresh your memory. Now, a perfect square that goes into 24 would be 4, because 4 times 6 is 24. So we're going to write this as x equals plus or minus the square root of 4 times the square root of 6, because that can be simplified to x equals plus or minus 2 times the square root of 6. All right. Now let's do the next one. Letter D, x squared equals 56. Well, this one's kind of nice because x squared is already by itself. So we can just go ahead and take the square root of both sides. The downfall of this one is that 56 is not a perfect square. So we just need to reduce this radical. Okay, let's think about 56 and what perfect squares might go in there. So let's think about 4. If we take 56 and divide it by 4, that actually does work. It's 4 times 14. And you guys can have a calculator out next to you to do that. So I'm going to write this as the square root of 4 times the square root of 14. And because the square root of 4 is 2, we're going to write plus or minus 2 times the square root of 14. Okay. Now, in the next couple examples, we're going to have a little more going on. Notice that the other ones we just had to add a number over. Well, now in letter E, I have 2x squared minus 16. So I'm going to have two steps I need to take to get the x squared by itself. The first thing I'm going to do is add 16. So that leaves me with 2x squared equals 16. And now I have to get that 2 off the x squared. So I'm going to divide both sides by 2. So I have x squared equals 8. Now we're to the point where we can take the square root of both sides, and that will give me x equals plus or minus the square root of 8. And we ask ourselves, are there any perfect square factors of 8? Of course. 4 goes into 8 2 times. So my answer would be x equals plus or minus 2 times the square root of 2. Okay, let's look at letter F. Getting our x squared term by it, or just x squared by itself, we are first going to have to subtract 9. So now I have negative 5x squared equals negative 9. Now I need to divide by negative 5, which cancels on the left. And on the right, you need to be very careful when this happens. You have a negative 9 divided by a negative 5. That is a positive number. So when you write this, make sure you just write this as positive 9/5. And also, do not put a decimal. We want to keep this as a fraction because what we learned about taking the square root of fractions. Because now our next step is to take the square root of both sides. And remember, when we take the square root of a fraction, we can separate that radical and take the square root of the numerator and the denominator separately. So I can write this as x equals plus or minus the square root of 9 divided by the square root of 5. Okay, well, we know the square root of 9 is 3, but the square root of 5 cannot be simplified. And remember, we do not want a radical in the denominator of our fraction, so we have to rationalize. To rationalize, remember, we multiply by what we do not want in the top and the bottom. So we can't have that rad 5 in the bottom, so we're going to multiply by rad 5 over rad 5, which gives us, still going to have plus or minus, I'm going to have 3 rad 5 over rad 5 times rad 5 is rad 25. So that's the square root of 25, which we know is 5. So if you did not have to write that step in the green, that's totally fine. I just wanted to put that there for us. So our final answer is plus or minus 3 rad 5 over 5. Okay, guys, we will do the last 3 problems in class tomorrow.